Welcome back, everyone, to another exciting episode of CPP4Beginners.com's continuing tutorial series on learning C++. I am your host, Damien, and I apologize if that was a little bit loud. I am just very excited to be getting this lesson done with, finally. So, you'll have to pardon my prior enthusiasm. Okay, what we're going to be talking about here is strings, and strings? I'm an idiot. Sorry, I was just reading the include. Pointers! And we're going to be talking about them in more depth than we had before, because pointers are a good way to solve a lot of problems. And understanding how to use them effectively is going to make our life a lot easier when we get into linked lists later on. So, everybody remembers how we were declaring our pointers earlier. So we were starting off with a data type. So in this case, we're making a pointer that's an int, and we'll call it a IPTR. And what we're going to do is we're going to treat IPTR exactly as though it were an array. So we'll make it an array of new int 5, which is basically the same as creating an array with 5 variables. So this is the one that we would normally initialize 0 to 4. So there's a few different ways that we can manipulate what's inside this array using our pointer. We can do something like this. I believe it's PTR, let's say 2 is now equal to 50. Oh no, it has to be like that. I'm sorry. What's the problem here? Oh, duh. No, I was right. It's supposed to be Sorry, my own variable naming scheme's coming back to bite me in the ass. So, if this doesn't look right to you, it's because it's something that we haven't really used before. We haven't really not dereferenced a pointer and set a pointer equal to values and things like that. So let's try so if we just see out this, we should be expecting to see 50, which comes out. Now, if we were to try the same thing with iPointer of 1, you'll notice that, of course, the thing crashes. Hang on. Alright, I'm back, and sorry about that. I just switched over to external terminal again. They'll eventually fix it. So, if we call an iPointer of 1, you'll notice that we get 0, which means that it was either initialized to 0 or it just didn't have anything stored in there quite yet. But here's an interesting thing that we can do. Assume that we're going to do iPointer of 1, and then, well, the reference to it, and then iPointer of 2. So what we should be expecting here is for these to be separated by the size of an integer, meaning if we're counting, 1, 2, 3, 4, the size of an integer in this case is 1. We're incrementing by 1. But in the case of C++, we're incrementing by the size of storage. So I believe if I were to do this, and then do a size of int, that should tell us how big an int is on the next line. So what we should be expecting here is for this to output the memory location of iPointer 1. This will output the location of iPointer 2, and they should be separated by the size of int in memory. So let's give that a run. And you'll notice that BC to C0 is indeed 4 bytes. Those of you who don't know hexadecimal, it's a base 16 numbering system. So it actually goes from 0 to F. So we'll get more into that later. But that kind of proves that we are actually using this as an array. To show you a little bit further what we can use a pointer for as an array, and this is actually the easiest way to use string copy. So what we'll do is we'll take a character pointer and we'll name it oh hi, and we'll set it equal to oh hi thar, how are you? Something along those lines, right? Now we're going to make another normal character array, and we'll call it FBP, filled by pointer. And we'll set the size equal to 256. Now all we need to do is type string copy, and then in our parentheses, FBP is getting the contents of oh hi, and then we cout FBP. And I should probably put that on a new line. So there we are. And we'll give that another run. And so you can see that it says, oh hi there, how are you? But we're actually using this oh hi as an array of characters. And we're copying it just by, putting the pointer in with string copy, because character pointers are an allowed source for string copy to be fed into. If you haven't noticed yet, you know how we've sort of used character arrays as the same thing as strings? They're not exactly the same thing as strings. If you want to have something that's almost exactly the same thing as a string, character pointer is really what you're going to be after. With all that said, we can talk a little bit more about how to access arrays, or pointers as though they're arrays, with different types of notation. This is something that you're really bound to see if you ever get into higher end programming, especially if you ever go from C++ back to regular C. You'll see a lot more being solved with pointers because they don't have functions that quite like we do, and classes the same way that we do. So a lot of C relies heavily on pointers. So assume that we wanted to print out just iPointer of 2. But we wanted to use it by dereferencing. What we would actually do is toss out the star and then say IPTR plus 2. And so what this actually means, to be very, very technical about it, is take the memory location of IPTR, and then add 2 of type star IPTR, of whatever type it is. So basically what we're doing is, in this case, instead of adding just normal 2, it's adding 2 size of type, and then figuring out what type IPTR is. And in this case, it's an integer pointer. So if we were to simply output the locations of iPointer, so we'll do ampersand IPTR, and then another endl, and then do ampersand IPTR plus 2, that actually might not work. I think it should be like this. I think it should be outside the parentheses. I've never actually tried to dereference or to output the pointer arithmetic reference before, so we'll see if that's the right notation. Yeah, in this case, that's actually wrong. So I'm going to try doing it like that. I don't know if that'll actually work, though. We'll see. 2c to 3, 4. Yeah, that's 8. So in this case, what you'll see is that IPTR of 2 is pointing to 50. Now, when I use the address, that's the address, and then of just I pointer. And this right here is the hex address of I pointer plus 2. So it's just a little way of showing you that, we are actually dealing with different memory locations. It's not really any kind of hocus pocus. It's really just another way of, accessing different locations inside of an array, but without having to necessarily declare the array. The only other thing that I can really mention is if you're going to be working a lot with pointers, I'm going to be including an excellent tutorial after the next video that talks a lot about how you can use pointers in different ways, because I haven't really covered how they're actually useful. I'm showing you how they work and, how to use them and reference them. I haven't shown you, how they're actually useful yet. But I'm hoping that we can see a little bit about how they're useful in the next lesson when I show you guys how they interact with objects, because that's extremely useful. Alright, well, my name is Damien. Hopefully you guys have enjoyed this. Hopefully I can find the window to stop this. If anybody has any questions, please let me know. Drop a comment in the thread where this is posted. Post a comment below. I don't know. Hit me on Reddit. Whatever you want. I'm available. Alright, have a nice night, everyone, and see you next time for more commentary on pointers. And then, I think after next lesson, we're going to be moving on into our case study. So, see you then.